Hello everyone. Good evening. Can you hear me? Hello. Okay. Can you hear me now clearly? Yeah.
Yes, I can hear.
Okay. Okay. So basically today there is also no electricity, so that's another problem. So now I am staying in my hometown, so in the rural area. So that's a very difficulty for the all-time load shedding, and network connection is very bad in here. Okay. So we face some problem about that. Okay, so no problem. We are waiting just 1 or 2 minutes for joining all of the other participant. Then we will start our today's session. Okay, so just
Excuse me, I cannot hear.
okay. So now we'll start. Okay, so just we are waiting some 1 or 2 minutes. Okay, so now we'll start our registration. So let's go. I simply share my screen. Okay, so now can you see my screen? Is it visible? My skin.
Yes, sir, I can see.
Okay. Okay. So hi and welcome. The 7 days online training program on Google Earth Engine. So basically, from today's, we also try to discuss a map how you can really perform using the different types of machine learning in Google Earth Engine platform. Okay, so let's go. So basically, when you want to make the land cover classification map using the Google Earth Engine platform, we have just follow the some process or step. Any kind of land cover classification map, when you can classify it, just follow the process and you can easily create any types of land cover classification map. So first of all, you have to selecting your ROI. First of all, which region you want to need for the land use land cover classification map. Just select this region. Okay, suppose you want to make the land use land cover classification map for the Dhaka city. Just simply import your Dhaka city boundary shapefile. You want to make the land use land cover classification for the Delhi, you can simply import the Delhi city boundary shapefile. Which area you want to classify it, just simply import this boundary area. It's the first step. Second, you need to choosing and filtering the image collection. If you want, you can use the Landsat image or Sentinel image. You can choose, and then this image collection you need to filter. Okay, so about the image collection or filtering the image collection or how can you filter, lot of time we discuss about the image collection, how can easily filter. Okay, so this is our second step. You need to choose your image. You want to use the Landsat, then filtering the Landsat image collection. You choose the Sentinel, then filter the Sentinel image collection. Okay, after that you need to collecting the training point. Okay, so basically it's a supervised machine learning method. So supervised machine learning method, we need to collect the some training point. So we can just simply from this satellite images, we can simply take the some training points, such as suppose you want to classify the water body, then you can collect the some training point from the water body. You want to classify the urban area, then you can take the training point from the urban area. You want to classify it for the build up area, then take the training point for the build up area. You want to classify the barren land, then take the training point for the barren land. Okay, so which feature you want to classify, just simply take the training point for this classes or for these features. Okay, it's third step. Then you need to merge all of those training point. You need to merging all of this training point, you can simply merge, and after that you need to use a function, this function called the sample regions function. This sample regions function mainly extract the band pixel value from your satellite images. Suppose you want to take the training point for the water body, so it extract the band pixel value of water body. You collect the training point for the suppose build up area, it extract the build up area pixel value. You collect the training point for the suppose cropland, it extract the band values from the cropland. Okay, so it's our data set. Okay, so after that, by using the sample region function, we create the data set. Data set mainly it stored the pixel value, different features. For different features, it is stored the pixel value, and this pixel value, it's our data set. This data set we divided the two part. Some data set we are using for train our model, and some data set we also use for the train our model. It can be 80% data for train your model, or 20% data for test your model, or 70% data for train your model, or 30% data for your test your model. Okay, so these data set we divided into two way. So some data set, suppose 70% data I use for train my model, and 30% data for check about the model accuracy. Okay, so after getting this data set we divide it. Okay, then we need to create the classifier. So in this time, Google Earth Engine platform has a lot of classifier. It can be classification and regression trees. It can be random forest. So we need to create the classifier, and using this classifier, classify the image. Okay, and create the classified image, and then display the result of this classified image. Then we also need to print the confusion matrix for accuracy assessment. Using this accuracy assessment, from this confusion matrix, we can easily calculate the different types of accuracy, such as kappa coefficient accuracy, overall accuracy, then producer accuracy, consumer accuracy. So this type of accuracy we can easily calculate in Google Earth Engine platform. Okay, then calculate the area for each classes. Suppose how much vegetation is available, how much area for the water body, how much area for the build up area. So this type of calculation we also try to show you that how we can easily do that. And finally, we can export the map, and using the ArcMap software for creating the map. Same process, we already discussed about that, how we can easily use the ArcMap software for processing your map. Okay, so let's go about that. We try to show all of the things for the practically, then it's so better. So for that, I simply open a new code editor. Okay, so first of all, first step is that we need to import our boundary